Need to onboard a lot of computers to Azure Arc at scale? In this video, I'll show you how to do it with Azure Service Principals. Hey everyone, I'm Travis and welcome back to the channel. In a previous video, I walked through what Azure Arc is, why you might want to use it for both Windows servers and clients, and how to deploy it. But there was one big limitation with that approach. The onboarding script required you to log into Azure every time it ran. That works for a demo, but it doesn't work at scale. So in this video, we're going to take that same Azure Arc onboarding process and level it up by creating an onboarding script that uses service principals, enabling you to deploy Azure Arc-enabled servers at scale. Before we jump in, please like the video, subscribe to the channel, and share this with a friend or colleague. Also, check out my courses at udemy.com. Those links are below. And as always, a huge shout out to my channel members. Your support is appreciated. All right, back to it. Azure Arc extends many Azure management features to computers that aren't running in Azure. So even if your computers are on-prem or in another cloud, you can still manage inventory, use Azure Update Manager, create configurations and onboarding tasks, and push custom script extensions all directly from Azure. If you want a deeper walkthrough of those basics, definitely check out my previous Azure Arc video. In that earlier video, Azure Arc was deployed using an onboarding script that required an interactive login each time it ran. That's fine for a handful of machines, but it's not scalable. In the demo coming up, we'll use a service principal instead, which is a better option when you're onboarding computers to Azure Arc at scale. An Entra ID service principal is a management identity that's granted only the permissions it needs to perform a specific task, in this case, connecting machines to Azure Arc. It's safer than using a highly privileged user account and aligns with zero trust and least privilege access principles. Beyond security, there are two big advantages to using a service principal in your Azure Arc onboarding script. First, it eliminates the need to log into Azure with elevated privileges. A local admin on a server with no Azure credentials at all could still run the script and onboard that machine into Azure Arc. Second, if you're using automation tools like SCCM, group policies, Ansible, or CI/CD deployment pipelines, a service principal makes full automation possible. There's no interactive login required, which is exactly what you want when you're deploying a large number of Arc-enabled servers. There are a few requirements to be aware of. The account that creates the service principal needs either the application administrator or cloud application administrator role in Entra ID. And it also needs owner or user access administrator permissions on the Azure subscription where the machine will be onboarded. From a networking standpoint, the Arc client needs outbound access over TCP port 443. I've included a link to the required URLs below in case you need to further lock down outbound traffic in your environment. And if you'd like to follow along with this demo, you'll need a Windows computer to onboard and of course an active Azure subscription. With all that out of the way, let's jump into the Azure portal and get started. Here we are in the Azure portal. To get started, we'll go to Azure Arc and create a service principal. From Azure Arc, go to Additional Setup, then Service Principals. We'll add a new service principal. Give your service principal a name. Select if you want the service principal to have access to the entire subscription or just a resource group. This example will only use it for one resource group. And this is the resource group the service principal will have access to. This is where the Arc-enabled computers will go. Next, we'll update the client secret information, give the client secret a description, and select when it will expire. The secret should be valid only as long as we need the account. This example, we'll just use 1 day. We can also add a secret with a different expiration date if this one expires. We'll see that coming up. Select the role assignment. This will be used for Azure Connected Machine onboarding. We also have the option to onboard Kubernetes clusters or for a Connected Machine Resource Administrator. Once it's all entered, click Create. That creates the service principal, and we'll get a prompt to download the principal ID and the secret. We'll need this information coming up. Select Download and Close. We can take a look at what it downloaded by going into File Explorer, Downloads. There's a text file. That text file has our service principal ID as well as the secret. We'll close that and save it for later. By the way, if you need to delete an existing password or maybe it expired and you need to create a new one, we can do that by opening up the service principal. In the overview page, we have the application ID. That matches the ID we downloaded. If we go to Manage, Certificates and Secrets, from here we can remove an existing secret or we can create a new one. Now that we created the service principal, we can move on to creating the installation script. Let's go back to Azure Arc, Infrastructure, then Machines. Select Onboard Create and Onboard Existing Machines. This is all the same as the last video with the exception of the authentication method. Select the subscription and the resource group. This is the resource group where the machine objects will be placed. It should be the same as the one selected for the service principal. Select the region. This is the region the Azure Arc connected machines will be placed in. And the operating system is Windows. There's no SQL servers in this demo. We can uncheck that. For connectivity method, leave it at public endpoint unless you're using a private endpoint. If you have a proxy server, you can add that URL here and select Arc Gateway if that's in use. Finally, add authentication, select Authenticate Machines automatically. Next, select the service principal we just configured in the last step. Go next to Tags, add tags as needed, and then go to Download and Run Script. Notice at the top we have the options for Basic Script, SCCM, GPO, and Ansible. Select one of those options if that matches what you're using. Group Policy has some additional configuration. We'll stick with a basic script to show how to use the service principal for this example. However, as you'll see coming up, it's a good idea to leverage an automated deployment solution. Let's scroll down and select Download to download the script. And if you get the warning, of course, we want to keep it. Now that we have the script and the credentials, we can move on to onboarding a computer. Let's go back to Azure Arc and take a look at what we have in the environment. We'll go to Machines. We just have one of the two session hosts in this resource group. Let's add the other computer next. Here we are in PowerShell ISE. Not my favorite IDE, but it's already installed. The first file we'll look at is the service principal text file. This has the service principal ID and secret. That was downloaded in the last step when we created the service principal. Then we have the onboarding script. An important step is to make sure the service principal is added and update the secret in the onboarding script. Scroll down to the Add the Service Principal and App ID secret section and update them from that text file. Be sure not to include the equal sign or any other extra characters and don't miss any either. Otherwise, the script will fail. Once that's updated, be sure to save the file. Okay, now we can onboard a computer with the script. I need to pause the video here for a quick call out because this wasn't the ideal example I originally had in mind. My goal was to onboard a computer to Azure Arc with little to no interaction on the target machine. That didn't quite go as planned. To make this work, the remote computer needed to be joined to the domain, and I had to log in manually and run the winrm quick config command to enable PowerShell remoting. At that point, I could have just run the onboarding script locally. There are two key takeaways from this experience. First, even when the script is run locally, it's still more secure because it doesn't require logging into Azure with elevated credentials. Another team member without any Azure access at all can still run the script and onboard a computer. Second, it was a good reminder that the right tools are needed to administer systems at scale. PowerShell remoting isn't an enterprise-grade solution, and in many environments, it's disabled entirely. So while what I demonstrated here does work, it's not something I'd consider a fully scalable enterprise approach. All right, let's get back to it. I wanted to demonstrate doing it remotely But that isn't as easy without real automation tools like SCCM, Ansible, desired state configuration, or other tools like that. So I used PowerShell remoting. To get that to work, I had to join the computer to the domain and enable PowerShell remoting. Both are less than ideal options for scalability, but I did get it to work. The script starts a remote session to the computer that's getting onboarded. It then copies the script to that remote computer. Then it runs invoke command with a script block that sets the execution policy and runs a script. I tried this with the invoke command file parameter instead, but that doesn't have an option for setting the execution policy. And we need to set that for unsigned scripts to run. This again is why they make enterprise automation solutions. Then it ends the session. Let's run that and give it a minute to finish. The video will pause here and come back once it's done. Okay, that finished. And now if we go back to Azure Arc in the portal, we'll refresh. And there it is. That is how to use a service principal to onboard Windows machines to Azure Arc. That's how you create an Azure Arc onboarding script using a service principal. Please don't forget to like and subscribe. And as always, thanks for watching.